So we were thinking about doing a little section called chicken lips here, and I haven't explained to Fran what that is, but that kind of ties into the Commodore Vegas Expo, Convex, that's what it's called, which you can find out more about at portcommodore.com. But one of the things I'll be doing is a video on this, if you can zoom in. There's maybe 3 of these in the world. This is mine. And if we zoom in, can you go right here? What this is, Commodore looked to make their own LCD machine back before the Commodore 128. So there's a whole story that goes along with this. And Fran, if you look at that shape right there, yeah, chicken lips. That's what the Commodore people call it. So that's our inside name. That's
inside stuff, Bill.
Yeah. So, all right. Well, maybe see you at Convex, or check out portcommodore.com. Well, you said you're lucky, or the luck you had, and that's the way I felt. I worked at Commodore in the 1980s, doing home computers, and I got the job through sheer luck. Just right place, right time. Why a hippie-ish high school dropout could end up in a role like that was just, fate of the cards. But then, it's keeping the job was the fun part. And I don't, of all of us, I don't think any of us were worried about losing our jobs. We were worried about not getting something done. That was the distinction, I think.
You were never worried about losing your job?
Not once while I worked there.
Oh, okay. So that's why everything just went to hell when you showed up and.
Yeah, I just get the hell out of the way.
So you were sort of immune. You couldn't be fired. You couldn't be replaced.
They had no way to get it done without me. So as soon as the project's done, sure, there's a target on my back. So I tended to, I do a lot of fishing for the first 2 months after a project's done.
Well, didn't you tell me about the high turnaround with jobs, like
was
back in those days? Your job was like it had a finite, like there was a period of time.
Well, some people had a finite mentality. And so if you worked at a great place like Commodore, what would be next? And when I quit because I thought the place was going under faster than it did. So it still went under. It's just it took a lot longer to die, because the other guys that stayed, they loved it for the next 8 years. But that's in dog years. That's like 76 years. That's cool. I came from the opposite of that. Then coming from Commodore, where it was all about the, if I could shave a dime off the board, that's, $10 million at the end of the day, or something. So yeah, I was all about the, the math of low quantity. And, I used to be on the CBM hackers group, and they're talking 35 years later about these chips, or 30 years, whatever it is. And they've it's completely different. That wasn't important to us, that the chip did this one mode so you could do a thing 30 years later. No. How many ended up under the Christmas tree? That's all it was about, And if the features help drive more, that's great. So we also found shipping the bad units helped our bottom line too.
Shipping the bad units helped your bottom line.
Absolutely.
How does that help your bottom line?
Well, you'd have a skid, and the sign on it says broken, and then you take the sign off, and you just now produced another skid of Commodore 64s, and so it'd go out the door, get marked up, and if you got a bad 64, you still got a 64. If you bring it back to us and we give you a good one second week in January after it's calmed down some, we still got a sale out of it. So it's the opposite of Frantone.
Yeah, exactly, because in Frantone you sell a bad pedal, it ruins your whole company, you ruin your reputation.
Yeah.
But, well, I think what you're really demonstrating, though, is the difference in not only philosophy but also the production methods of medium scale versus massive scale production.
Yeah. We did things like we stopped plating through the holes.
You stopped plating through the holes?
And we started using a process of blowing air through it and using the solder itself to make a plate through a hole. And that was brand new back in the 80s when they
blowing air to get the solder to, well, so from the bottom, like when you're...
Yeah, at some point in the process when they're making the board, yeah, it'd be making the board instead of...
So
but instead of inserting a flow-through, they did a blow-through.
That was only two-layered stuff.
That's
it was two-sided.
only two-layered.
All right, and so, you know, I imagine...
Right, yeah, you couldn't do hidden vias or something.
We were doing wave soldering for that. It was all like board wave soldering, like you would put, the board would go actually over...
Probably a drag solder, maybe wave solder, but probably drag solder.
So it would actually, the board would actually go over the tank of solder and
for soldering the components, but when you're making the board, they can do anything they want to.
But I'm saying to get the solder up through, then there would be a second process, like after you've actually soldered.
Yeah, when you're
you
doing
would reflow
yeah.
and somehow get it to wick through the using the through hole leads, I guess, right?
Right. Yep. And so there's a lot of things that we did.
Well, it sounds like the measure of
Show
quality.
Me your boards. And for those that know my story, I got my first job as an associate engineer because I knew one of the facts out of that beat-up old analog data book. And it's just I'd read it cover to cover. I'd sit in the bathroom and read it and everywhere else. And I pulled a fact out of it, and that's what got the attention of the guy hiring. So it's so I got that from Radio Shack. So that's the kudos for you. Now, I don't like Radio Shack.
Today.
They screwed us. No, back in Commodore days.
Oh, okay.
The Commodore LCD computer.
Uh-huh.
That was probably after the 64. The LCD would have been innovative. You know, we had our own LCD company. We made LCD glass. We're the only people in America. And there's an article about this. Marshall Smith, our then president, he had been supposedly president of U.S. Steel, except later U.S. Steel said, we don't know who you're talking about. He had a meeting with the head of Tandy, Radio Shack, who convinced him that there is no money to be had in portable computers. And our guy believed him. And the guy who was head of the project at that time, Jeff Porter, had sold 15,000 just at the CES show, and they canceled it even though we had sales in hand. Huh. So shame on Radio Shack for telling, well, not really. Business is war, as Jack Tramiel would say, but shame on our guy for believing him. And that's what I said. So I always, when I hear Radio Shack, I'm like, the guys that screwed our LCD. So.
Well, I'm sorry to hear
that, We got you.
Bill.
20 years later, we chased you to. Now, when I worked at Commodore, the way we had worked up through the Commodore 64 is America, you know, the U.S. company, we'd lay out a board and then ship it to Japan, and they'd lay it out again because they laid it out to pan-assert rules, which was on the auto insertion. They would come in from the end of a component. And on the 128, what we did is I got the engineer over here, and he sat down with our guy Fish. So anyway, he'd sit down with our PCB guy, and we laid it out for both so that Universal, which is the American standard, could come in from the side and Panasonic could come in from the end. So it was the first computer board we did at Commodore that didn't have to be relayed out once the Americans were done with it.
So they had a whole different kind of insertion
tool
method. I mean, the tool.
It was a different tool.
Now, was that automated? That was the automatic.
Yeah, it was auto insertion at those quantities. Yeah.
So in those days, the pick and place machines weren't standardized like they are today.
Well, there was an SMT, and so any pickup with vacuum or something, we didn't do that. It was all with, you know, the leads on tapes, and there was a crimper, and they'd push it in.
It'd be on, you know, the like machine gun rolls, you know, the way they used to come on a tape.
And I've been to where we did our prototype runs of only 10,000 or 50,000 because it's Commodore, right?
Only.
Yeah, and it was and literally a room, huge room, but the 2 or 3 guys running from machine to machine. A light would go off and it'd stop, and he'd run and fix it, and we just sat there watching them running around. It was pretty funny. It's like those things with the plates, you know. But they did, and so then the real production was somewhere else. It was just couldn't even think how big that area was.
Well, these days, I imagine that's pretty standardized now. I don't think are there really variations now?
Yeah, I mean, there's different quality, you know, pick and place machines and stuff, but you know, it's what
you wouldn't have to design a board differently now for different kinds of assemblies.
Well, you do some things, a little bit of clearance. For maybe around the head and stuff, don't have it too close up to something, but the differences I know mostly about would be don't put a via under a resistor or something, so that when it does you know, solder or anything like that. You don't want it sucked up under the component.
Talking surface mount.
Yeah, if you're doing a mixed surface mount through a hole, and if you hit a wave solder. So, you know, I don't know the rules offhand, but most people tweak the pads so that there's a little more pad, so surface tension will pull on the part better if it did get a little misaligned, things like that. But there's a whole science, as you know, engineers aren't just design engineers. A production engineer can know all about that, but never have designed something, you know, and vice versa.
But
yeah, I never, well, it's just something in the Japanese language. The word for bug is mushi. And when you answer a phone, you say mushi mushi.
Mushi mushi.
Yeah, so I used to say bugs, and they would, and you know, they'd laugh every time, so I kept doing it, and it's like, that's because they're, you know, they're polite by training. And we asked one time, I said, well, us Americans must be horribly rude compared to you. They said, no, actually, when you're nice, you mean it, whereas we will always act nice. And so I was like, wow, okay. Then I started back to acting rude.
Domo.
Domo arigato, because
Origato.
I must.
Mushi mushi. That's all the Japanese I know. Origato and mushi mushi.
I was going through the customs in New York, and the Japanese gentleman in front of me had little packets of dried clams. And the guy from New York was from New York, and he let you know it. And the more the Japanese gentleman proved he didn't know English, the louder the New Yorker got. And now it's starting to hear my eardrums, and I'm behind. So I chime in. I start kind of doing some childlike translation for him and everything. But the last thing I said after he'd been totally abused by this guy, I said, "Welcome to America." So and so he got introduced to New York. Heads up.
Well, welcome to New York anyway.
Yeah. Well, I always had problem with customs in New York. Have you ever traveled with computer equipment and stuff?
In New York.
Well, I'd be coming in. That's where we'd land on a polar route.
No, I've never flown internationally. So
okay.
Yeah.
So
they won't let me out of the country. So you know.
Well, back when I worked for Commodore in the 1980s, if you were going to the Japanese office, you'd be a mule. They'd load you up, and so you had to learn how to survive the trip. Like, they would put those plastic bands on boxes for you that cut the circulation and eventually cut your fingers off. Look at this, lost a finger. So you learn to like get duct tape and a towel and make handles out of them and everything. And then on the boxes you know they're going to open in customs, you put another roll of tape and you know everything you need in the box, and when it's opened you can seal the box. But then one time in customs, New Yorker guy again, he's like, I have to see what 50,000 keycaps look like, because they're 0.01 cent each, and it was keycaps for the computer. He opens them, they go everywhere, and I just looked at him and said, you now own 50,000 keycaps, and I walk off. He's like, hey, you can't leave. Not mine anymore. And I left him. We had to call the broker to go back and get him. But the way I looked at it, because I didn't put a roll of tape in that when he tore the box completely open. Keycaps everywhere.
But you did get them back. You did get them
I don't know.
Oh,
yeah, well, I'm sure we got some back.
It's a mystery.
Yes.
It's one of those Commodore mysteries.
Well, helped my reputation for don't load me up too much with.
Well, your reputation is quite solid. So.
When I first went to work for Commodore back in 1982 or 83, we had a brand new chip called the TED, Text Display Chip, and basically we were getting more and more into getting as much computer onto a chip, and that came from Jack Tramiel. He said, we owned a chip company, we owned a computer company. He said, you will do this. So the tools back then, we didn't have an electrical rule checker, an ERC. So if you had the schematic, the guys, what they would do is print the chip and then use little scales, can't call them rulers, I found out, and you had to measure every gate and do all this, and that's how you proved the schematic was good. And then there was a design rule checker that would tell you if the metal traces got too close to each other, but if a metal trace went right across three other ones, that was fine. Nice cleanly across them. If you got close, it'd flag it cleanly across. So we didn't have the ability to write to the register that controlled NTSC and PAL mode. And they didn't want to wait for, a month for a whole new run of the chip and everything. Plus it's like probably about $250,000 to $500,000 depending on the size of the run. So they're over there. It's like my second week at Commodore. And the guy, Bruce Ahern's working with Dave DiOrio, and he says, okay, yep, turn on the microscope light. Okay, turn it off. Yep, we're in NTSC mode. And I look and I go, did you just use the photons from the microscope to flood the register and flip the bit? He goes, yeah, And I'm like, I'm in the right place. I am so working in the right place, because there it is. Photon equals energy equals the bit flipped equals now we can test NTSC mode. So that was so cool. And it showed troubleshooting at the coolest level, you know, where nobody says, we couldn't do it, you know, it was broken. No, we found a way to make it work. So I'll tell you more of those stories, because we always had to find a way to make the chips work.
Well, that's what the Dino Den's all about.
Right.
It's about the great ways that we used to do it.
And the programmers hated it because they were always the people that could change stuff at the last moment. So we made them like change everything for us. Cool. They resented us. So one last thing we wanted to pull out today. This is just something I was walking by a few minutes ago and said, hey, let's show you the passage of time. And if you saw a wafer these days in a at a chip fab, they're this size. They're like dinner plates, frisbees. So say 4.5. That's what we had back then. This is from the old MOS technology back in the 80s when I worked at Commodore. And what's kind of interesting here, one, we used to try and break these. I had a piece of wood. There we are. First off, when you sail them, they fly like a frisbee and then they break like glass. So it's pretty cool. You see people knocking it out of their hair and everything. But I would see people with these things and they'd have them cleaved into 4 or cleaved into 5 pieces, and it was based on which kind of silicon, how the silicon crystal, which one they had. But I never could do it. I would take this, and there's a way to tell the alignment of the silicon. If you see, there's a flat edge there. So that is the alignment of the silicon. So I was making that parallel to the desk and thwacking it, and I'd get glass all in my hair and stuff. I went through 12 of these things, right? So finally I learned that the way you cleave a wafer is you take a pencil point right in the center and hit it, and it'll break into 4 nice pieces. But this is an old ROM array from the 70s, and again, 4.5 inches. Think about that. You have to do all the expense of running a wafer, but you'd only have a couple hundred die to choose from, or if it's a processor, you might only have 60 or 50 to choose from, and of those, only 10 might be good. So, oh yeah, here we go. Talk about. Here's what a cleaved piece looks like, just to prove you can do it. So, matter of fact, can you see the little computer part there?
So will that break into quarters if you just push the center?
That'll shatter if you do it again.
But if you push just the center, it'll actually split into.
That's how these were done. Is somebody? Matter of fact, see the divot right there?
Are they scribed ahead of time? Or?
No, it's the crystal.
The actual
crystal and structure, right?
Huh.
And so, like I said, I had a chip guy had to tell me, well, you better hope they know the physics of it going on. So, and again, these make great frisbees, but I'm down to my last one, so I won't be throwing this anytime soon. So, oh, I get asked, oh, do you use a Commodore 128? My answer is, if I really needed one, I would just simulate it on my 3 gigahertz Pentium, you know. Because back then, the fastest computer had an 8 nanosecond cycle time. That was the Cray XMP, and we were like, oh, 8 millis, you know. And now you've got one at home. So you live in an exciting time, and we're here to remind you of that.